We need to know that velocity is a vector, so it tells us both how fast you're going and which way you're going, both speed and direction. So as maybe you've already seen in class, they like to test whether we can see the difference between velocity and speed. Well, the speed is like an aspect of the velocity.
The speed is the absolute value of the velocity.
Yeah, that's one way to put it. A slightly better way to put it is the speed is the magnitude of the velocity.
Okay.
All right. The instantaneous speed is the magnitude of our instantaneous velocity. Okay. But the velocity also has a direction. And we've also described now, how do you indicate directions? Well, for one-dimensional motion, the two ways to indicate a direction are with a word or with a sign. For one-dimensional motion, we can indicate the direction with a word or with a sign. Now, for two-dimensional motion, it's going to be trickier. For two-dimensional motion, you can't really use a sign to indicate the direction, so we'll get to that next week, but this will work for one-dimensional motion. What would be a good unit, or what would be our standard SI unit for velocity?
Meters per second squared.
Stop and think about that again a little bit. I think you're jumping ahead to acceleration.
Meters per second.
Right. That was our unit that we were using here. And again, that's not the ordinary unit in the United States. In the United States, we usually use miles per hour, because that's what the speed limits are in. But the standard SI unit in physics is meters per second. Just like everyone knows, if you say you're going 50 miles per hour, that says how fast you're going. Well, if you say how many meters per second you're going, that also tells us how fast you're going. You can see that these units are just based off these units here. So all our units have to be consistent with each other. Something else that's important to understand about the velocity is that the velocity describes the motion of the object.
Yeah, so they really drilled it in so far that the velocity is the slope of the position versus time graph. But I don't know that I totally understand what that means.
Right, okay. Now that's something that I've never seen appear on an exam, so I don't know how much time we want to give into
really?
that.
Okay.
That's like I'm saying, it's amazing how much time they spend on stuff that never appears, or that I've never seen appear on an exam, basically.
So
That's the truth about the way the course is. So anyway, the best thing is to go over the stuff that it does appear on the exams a lot, and then if we have more time, we can go back and talk about the graphs. Okay. All right. So this is the key things that we need to know about the velocity. It describes the object's motion. So if you're going to describe a vector, a good way to graphically represent a vector is with an arrow. So we can describe a velocity like this. What would this tell us about this object? Well, this tells us that the object is moving to the right, or possibly moving east, depending on our interpretation. I'll say it's moving east, depending on how we interpret the blackboard. We could say it's moving to the right or moving east. What can we say about this object? Well, which way is it moving?
East.
What's the significance of the fact that this arrow is twice as long as this arrow? Do you know what that means? So that would mean that this object is moving east twice as fast as this object over here. So the length of the arrow tells you how fast you're moving. This is just the convention for dealing with a vector. So the arrow tells you what direction you're moving in, and then the length of the arrow tells you is proportional to how fast you're going.
Are vectors a calculus thing?
No.
Oh, okay.
Yeah. You can use calculus to talk about vectors, but no, they're not really standard calculus.
Oh, okay, I just wasn't sure if that's something that I didn't
Right.
know about. Okay.
Yeah. No, this is just a basic idea about vectors. It sounds like maybe your instructor hasn't quite mentioned this yet, but he's probably going to go over it tomorrow. So
He did it today, but
okay.
I don't know what a vector is.
Okay, all right, well, let's try to clarify that again. Now, we've already seen that a vector is a variable that has both a magnitude and a direction, and now we're learning that it's conventional to represent vectors with arrows. You can represent a vector with an arrow, and now we're learning how to interpret these arrows. So obviously, the direction of the arrow tells you what direction the vector is in, and the length of the arrow is proportional to the magnitude of the vector. So for example, for velocity, the magnitude of the length of the arrow is proportional to how fast you're going. So if you draw a longer arrow, that means that the object is going faster.
Okay, but say you were saying like distance with an arrow.
Right.
And then you had another one with a longer arrow, that would still tell you the speed, right? Or is that different?
If you're dealing with distance?
Yeah.
Well,
or is that the length?
Technically, we wouldn't use the term distance, we'd use the term displacement.
Okay.
Because displacement is a vector. So for example, that's a good question. So let's say that an object has a displacement that looks like this. Well, what does that tell us? That tells us that the object has moved east. The velocity kind of tells us what's happening right now, whereas the displacement tells us what's kind of happened in the past. This tells us the object has been displaced east. And let's say we have another object whose arrow looks like this. Well, which way has this object moved?
Twice as fast?
Right.
Or twice as much to the east?
Twice as far.
Twice as far.
Yeah, this has also moved east, but it's moved twice as far to the east.
Okay.
So velocity represents how fast you're going. So when the arrow gets longer, that means that you're moving faster. But displacement represents how far you're going. So when the arrow gets longer, that means that you've moved further. So this longer arrow means further movement, and this longer arrow means faster movement.
Okay, so then for acceleration?
That's right. So we're not maybe not quite ready to dive into acceleration. Let's put that off for a second and just understand these vectors. We'll get to that very shortly. Okay. So just to review, let's say that this indicates a velocity vector.
Okay.
Well, what does this tell us about the object? Would you say which direction would you say this object is moving?
Down.
Yeah, down or south. Good. Or the negative direction. That's right. Those are all good ways to describe it. And does it look like this object is moving fast or slow?
Slow.
Yeah. This seems like a very short arrow. The direction of the arrow tells us the direction we're moving in, and the length of the arrow is proportional to how fast we're going. Remember that a vector is funny because it has to have two different pieces of information encoded in it. Well, now we've seen how the arrow can encode two pieces of information.
Right, so it's length and its direction.
Right, yeah. Exactly. The length tells you about the speed, and the direction tells you about the direction.
Okay.
So how would you describe the motion of this object?
It's moving fast to the left or west.
Right. It's moving fast to the left or west, or maybe the negative direction if we chose.
But that depends on what we set as being positive.
That's right, absolutely. It's most of the time people would choose to the right as positive, and then it would be negative. But you're right, that depends on that. So the exact way we would describe the direction depends on what we're dealing with in the problem. Okay, so I think we have the basic ideas for these arrows, and we understand what the velocity tells you. It tells you which way and how fast the object is moving.
Right.
Which way and how fast.
And then I just am a little confused about average velocity versus instantaneous velocity.
Yeah, that's confusing. That's again a topic I've never seen on a sample exam.
Seriously?
Yeah, I'm serious. So I should have said what I've been talking about without saying so is instantaneous velocity.
Right, because
that's the only one.
What we're
yeah,
concerned with in this class.
that's right.
Okay.
The only concept I've ever actually seen on a sample exam is instantaneous velocity.
Okay.
By the way, the convention is, so if you were going to talk, the convention is, if someone doesn't say whether the velocity is average or instantaneous, you should assume that it's instantaneous, because that's by far the more important concept in the course. If they're talking about average velocity, they'd have to tell you so. Okay. So even though we haven't said so, this is the instantaneous velocity. Again, if we have time, maybe we can go back and talk about the average, because there is one or two questions about that in the homework, but I've never seen that on an exam.
And
so.
then you calculate velocity by doing x final minus x initial over the change in time.
That's right. Except that's how you would calculate the average velocity. To calculate the instantaneous velocity requires calculus, and that's why it never appears on the exams. Because
so you never have to calculate the instantaneous velocity?
I have never seen a question like that in an exam. And there's no questions like that in the homework either. Also, I noticed in the homework there was no calculus in this week of the homework. So they never ask you to calculate the instantaneous velocity in there.
So weird.
They will always tell you the velocity.
Okay, that's
Yeah.
very bizarre. Okay.
Okay. All right, like I said, I can't say for sure what's going to be on your test, but we should start the session by focusing on what's appeared on a lot of the past tests, and if we have more time, we'll get to the other stuff.
Okay.
All right, but there isn't even any homework questions that talk about calculating the instantaneous velocity because it requires calculus, and there's no calculus on this week's test. Okay. All right, so what the course really emphasizes is how to interpret the velocity, the instantaneous velocity, and that's what we just talked about, how to interpret that velocity. But the most important concept and the hardest concept from this week is acceleration, so I think we're ready to talk about that now.